Thank you for joining us today. And we just started Cartesian plane, and then we looked at some of the characteristics, and then we looked at the definition of Cartesian plane. So in this video, we are going to prove that A cross B is equal to B cross A if and only if either A is equal to B or at least one is what? Empty. Remember, when we were looking at the characteristics, we said this is not the same as that. This can never be the same as this. But we are also saying that for this to be the same as this, then it's either this is equal to this or at least one of them is empty. So if one of them is empty, then this one will be empty, this one will be empty, which will be the same thing, right? So let's look at how we are going to do this. So we are going to take them one by one, then we do them together, right? So the first one is we are going to let A to be equal to what? B. So if A is equal to B, then this implies that A cross B will be the same as. So if A is equal to B, then what happens? We are going to have B cross B, right? Because if I'm replacing the A by B, that's what I'm going to have. And we remember from the properties that this one can be written as B squared. So this one is going to be B squared. Or let me good. So this is going to be B squared, right? And this will be the same as B cross A, the same thing, right? Because if I have this cross this, I'll have it to be the same as this. And then if I have this one too, still here A is equal to B. So when I replace this one by B, I'll get B squared. So this is one, the other side when we are saying that A is the same as B. So when A is the same as B, then this is the same as that. So that is the one side. Now the other hand is if A is equal to empty or B is equal to what? Empty. So here we are assuming that one of them is empty. So if one of them is empty, then this implies that A cross B is equal to what? Empty, which is the same as B cross A. So they are all the same. If even A is empty, then this will give us empty. And then so since A is empty still, this is going to give us empty. Right. So if we've used the assumption, to prove that, okay, we've used the assumption that it's either this one is equal to this or at least one of them is what? Empty. So what we are going to do is we are going to assume that now this is the same as this, right? And A is not empty, B is not empty. Because we know that the only way that we can say that this and this are the same is when either this is the same as this or one of them is empty. So now we are going to assume that none of the values A and B is empty. And we want to prove that if none of them is empty, then actually or indeed A and B should be what? The same. So let's go through the process and see. So now what we are going to do is we are going to I'm going to let A cross B to be the same as B cross A, right? And I'm going to also let A to not be empty. A is not empty, right? And B is not also empty, right? So here A is not empty, B is not empty. It means that we have value in A and B. So if we are assuming that they are not empty, then for this one to hold, we should be able to prove that A is equal to what? B. If it happens that way, then we are going to say that indeed A cross B is the same as B cross A if A is the same as B, or at least one of them is what? Empty. So since we've done that, now it means that since A and B are not empty, it means that we have some values there, right? So we are going to let small a to be equal to big A and small b to be equal to big B, right? Since we are assuming that, so here, because we are assuming that they are not empty, then it means that we have value in A, we have value in this. So I can write something like since A is not empty and B is also not empty. So since these are not empty based on the assumption that we make, then we have a value in A, we have a value in what? B, right? So now what can we do? Then we can see that using the ordered pair, A and B belongs to A cross B, right? And this also implies that AB also belongs to B cross A, right? Good. So this is what you are going to get at the end of the day, because here we have assumed that A cross B is the same as B cross A, right? So this is assumed. That's what we started with. We assume that this is the same as this, and we are saying that none of them is empty. So what we are going to do is, since we assume that this is the same and this is not empty, then we need to prove that A is equal to B. So if that's the case, then if this is equal to this, or this is in A cross B, then this also going to be in B cross what? A. That's what we are going to get. And then what is going to happen? Now we can see that from here, we can see that A belongs to B. So from here, A belongs to B and B belongs to what? A, right? So this implies that A belongs to B and B belongs to A. But let's look at this side too. From here, we can also see that A belongs to A and B belongs to B. Right. So what can we see? If we are looking at this, then we can see that this implies that B is in what? A. As we were doing some proof that when we were showing that A intercept B is the same as C, right? You remember we did something like this, right? So from here, we can see that all the elements in B are in A. Is that true? Yes. A is in A, B is also in A. So it means that A is having small a and small b. Small a is in B, small b is also in B. So we can see that B is having A and B. So all the elements in B are in what? A. And all the elements in A2 is also in what? B. So since all the elements in A is in B and all the elements in A is also in all the elements in B is in A and all the elements in A is in B, then we can conclude that A is equal to what? B. We can conclude that this is equal to B. So this will end the proof that now we saw that when we pick the first assumption that we make there, A is equal to B, then indeed this is the same as this. And then if we choose any of them to be empty, then indeed they are the same. Then we started by assuming that, okay, let's assume that this is true, right? And none of the set is also empty. And we want to prove that this is also the same as what? B. So if that's the case, since A and B are not empty, then we have an element in A, we have an element in B, right? Since A is not empty, B is also not empty. Then AB belongs to A cross B, implying that AB also belongs to B cross A, since we are saying that this is the same as this. So it means that the element in this should be the same element in this, right? Then we distribute them. A goes to B, B goes to A, which is here. A goes to A, small b goes to big B, which is also here. And based on that, we can see that A is having element of A and B is having element of A and B. So A is in A, B is in A, and A is in B. Therefore, A is the same as B. I hope you enjoyed it. See you in the next video.